Good afternoon to all. Today topic is wave optics chapter verification of reflection and refraction of plane wavefront. The topic we are going to discuss right now. If you have any problem, you can write in the chat box. The topic is okay. Let us start. The topic is what? Verification of laws of reflection and refraction of plane wavefront. Okay, and I will write again. You listen very carefully. Heading is refraction of plane wavefront. Refraction of plane wavefront. Refraction of plane wavefront. Based on this, they may ask the question like this. That is, verify laws of refraction. Verify laws of refraction based on Huygens wave theory or the based on Huygens principle. This is our heading, today's topic, right? There is a refraction of plane wavefront. Refraction of plane wavefront. How plane wavefront undergoes refraction and how we can verify the laws of refraction based on Huygens principle that we are going to discuss, and you listen very carefully. And now let us start. And this is considered as a boundary. You see this? This line is the boundary. Boundary means it separates the two mediums. Above this boundary, medium 1 is there, and below this, medium 2 is there. Okay, and you see here, this is the medium 1, and in medium 1, the light speed we can consider as the v1, and this is the medium 2 below the boundary, right? In the medium 2, the light speed we can consider as the v2. And now let us consider the light rays are incidenting it here. You see here, we will take the two light rays. Okay, we will take the two light rays which are incidenting on the surface on the boundary. Okay, we will take the one light ray. This is the light ray. It is a light ray. It is incidenting like this, right? And another parallel light ray incident like this. You see here, this is there are two light rays are incidenting like this. These two are parallel to each other. Means these two light rays are parallel to each other. Means they are coming from distant objects. They are coming from distant objects. And now, when the first light ray incident on the boundary, the second light ray reaches this point. Okay. And here, this line, the line which is perpendicular to the light ray, this is called as the plane wavefront. When it will goes forward, when the light ray moves forward, then the plane wavefront also moves forward like this. And that plane wavefront is allowed to incident on the plane wavefront is allowed to incident on the boundary like this. This is the incident wavefront. Okay. And now this is the what? Plane wavefront. Plane wavefront. That is incident plane wavefront. And now this wavefront is always makes 90 degree with the light ray. This angle is 90 degree and this angle is also 90 degree. And now the first light ray travel A from here to here to reach the boundary. The second light ray travel up to B, up to point B. Okay, and two light rays are starting from the same location. But to reach the boundary, the first light ray travel less distance, but second light ray should travel more distance, right? That means when the first light ray, you see the figure and cursor, first light ray comes to here, at that time the second light ray is at B. That means first light ray incident on the boundary, but at that moment the second light ray not incident on the boundary, because to incident on the boundary it should travel some more distance. Now, when the first light ray travels some more distance like this in the straight line, okay, it is traveling some more distance in the same straight line. At that moment, okay, it travel from B to, for example, this is A dash, this is A dash. Okay, when first light ray travel from B to second light ray, this is the first light ray, this is the second light ray. When first light ray travel from B to A dash in time t, it travels some distance. The distance is equal to speed into time. We know that. And the speed in the first medium is v1. The time is t. Okay, v1 t is the distance traveled. And now we have to draw the normal at here to know the angle of incidence. Then let us see here. We will draw the normal at point A. This is the normal drawn, and the normal drawn at point A dash is this one. Okay, now I want to know the angle of incidence. What is angle of incidence? Incident light ray and normal drawn. In between this is called as angle of incidence, and this is called as the angle of incidence. Okay, and now if there is no change in the medium, then light should travel in the straight line path like this. You see the diagram very carefully and listen very carefully. From the diagram, we will get everything. And the light ray is incidenting like this, like this, like this, like this, like this. It will go in the straight if there is no change in the medium. But now the medium is changing. Due to the change in the medium, then its path will be changes and it will bend towards the normal. That means instead of going in straight like this, it will bend towards the normal. Then after the bending, it will go in the straight. And now let us draw the diagram. Now let us go for the angle of refraction. What is angle of refraction? You see here, this is the angle of refraction, and this is the angle of refraction. Okay, right? We have to draw refracted wavefront. How it will be there? Okay, you see here, the refracted wavefront will be like this there, right? You have to draw the normal at here for the first light ray, and now the refracted wavefront will be like this there. This is the 90 degree, and now this point we can consider as B dash. This point we can consider as the B dash. Okay. Now let us see the points that I am going to explain. And while teaching, if you have any problem, you can ask me, and you can tell me. And the point is that what is AB? AB is what? Incident plane wavefront. Incident plane wavefront. Incident plane wavefront. What is A dash B dash? Refracted plane wavefront. It is the refracted plane wavefront. Okay, let us verify now. For that, what we have to do it here. Now, I is what in the figure? I is the angle of incidence. I is the angle of incidence. R is the angle of refraction. Angle of refraction. Now you see this diagram and very carefully, and now we will write some information regarding this. That is, when second light ray, you see here, diagram very carefully, you listen, and one point I am going to explain. When first light ray travel from this position to point A, when first light ray travel up to A, the second light ray travel up to B. When first light ray incident on the boundary, the second light ray is at B. Then second light ray further it is moving forward from B to A dash. In that moment, the first light ray undergoes refraction. Okay, when first and it travels from A to B dash. That means in when second light ray travel, this is the second light ray. See the figure and cursor. When second light ray travel from B to A dash. Once again starting. When first light ray is at A, second light ray is at B. Second light ray going forward again, and the first light ray undergoes refraction and going forward. Second light ray travel from B to A dash and incident on the boundary. In that time, the first light ray travel from A to B dash. A to B dash. Now that means the first second light ray distance traveled. Here we thought we have tried the sentence that when second light ray when second light ray when second light ray moves from when second light ray moves from B to A, B to A, in that time, okay, second light ray moves from B to A. See the figure? Second light ray moves from B to A, B to A dash. In that time, in that time, first light ray, first light ray refracts and travel from B to A dash. Sorry. Travel from A to B dash. I will explain this one. Okay. And see here the diagram. First, second letter travel from B to A dash. In that time, the first letter travel from A to B dash. First letter diffracts and travel from A to B dash. Okay. And now, more point I will write. V1 is the speed of light in the first medium. Okay. V1 is the speed of light in first medium. Speed of light in first medium. And V2 is the speed of light in the second medium. Speed of light in the second medium. Right. And now distance traveled. Distance is equal to formula we have. Right. Distance traveled is equal to, we write the speed into time. Right. We write speed into time. Here the distance traveled by the second light ray. First I want. Okay, second light ray, how much distance traveled in time t? Second light ray travel from B to A dash. That distance is equal to speed into time. What is the speed in the first medium? That is a V1. Second light ray traveling in the first medium. V1 into t. And first light ray, how much distance traveled in that time? First light ray travel from A to B dash. That is V to t. Distance is equal to speed into time. You see here, when second letter travels from B to figure, you see cursor it is moving. When second letter moves from B to A dash, that is the distance is equal to speed into time, that is V1 into t. In that time, the first letter travel from A to B dash. A to B dash it is the second medium. That's why the distance is equal to speed into time. Speed is V2 and the time is t, right? And now next from the figure you see this is the angle I. Okay, and this red line light ray and this blue line is the plane wavefront that are perpendicular to each other. And when this angle is I, when this angle is I, this will become 90 minus I. When this will become 90 minus I, this, you see here, this is the 90 minus I. And what about this angle from the diagram? This angle, this total angle is 90, and this upper angle is 90 minus I. You see here, this angle become, this angle become 90 minus I. Why? Because combinedly we have to get the 90. And then this normal and black line boundary angle is 90. And then when you add these, this should be 90, this should be 90. In order to get that, this angle should be, this is 90 minus I, this should be I. Then sum of the two angles is, we will get, this is I. Okay, right. And similarly from the mathematics, this is R, this is 90 minus R, this is R you will get. Okay, this is very important. Now here we got R angle. Now I am going to derive the laws of refraction. Okay, and here the wavefront is incidenting like this. Wavefront is incidenting like this. You see here, wavefront is incidenting like this. This is the wavefront, like this it is coming, like this it is incident. After that, it will refraction, it will go like this. The refracted wavefront will be travel like this. This is the refracted wavefront. It will travel like this. Okay, right. And now I'm going to erase in the right side, and you take the screenshot and note it. And then after that, I will continue. We have to verify the laws of refraction. There are two laws are there. One is the Snell's law, and other one is the same plane. Okay, I'm going to erase. Okay, you listen very carefully now. Whatever the point that I'm going to explain that are very important, and you must listen very carefully. And any one question there is a chance to get for the 3 marks. And for that, you take the triangle. One triangle you take, that is a triangle uh, ABA dash. You take triangle ABA dash. From that, what you will get? It's a rectangle triangle. You write the sin I formula. Sin I is equal to what we write? Sin I is equal to opposite side by adjacent side. I opposite side is what? You see the triangle. I will show the figure. You see the cursor. ABA dash is the triangle. Okay, this is the right angle. This is 90 degree at here. This is the 90 degree. And 90 degree opposite one is said to be 90 degree opposite one is said to be hypotenuse. A dash is the hypotenuse, and I opposite side is BA dash. Then we write as BA dash. Opposite side by hypotenuse is A dash. But the BA dash, we derived that one, that is V1T by A dash we write. This is equation 1. And one more triangle we take, that is triangle A B dash A dash. A B dash A dash you take. So previously, that is what you got, A B A dash. And downward triangle you see, that is A B A dash. A B A dash. Here the sin R is there. We write sin R. Sin R, what we write from this? Sin R is equal to again opposite side. Angle opposite side. See the figure. R opposite side is A to B dash. A to B dash by this hypotenuse, opposite side by hypotenuse. Hypotenuse is again A dash, and then we will get as V2T by A dash we will get, and this is equation 2. And now we can find out the equation 1 by equation 2. If you will find out the equation 1 by equation 2, we will get sin I by Sin r is equal to, we will get as v1t by a dash by v2t by a dash we will get. Here a dash will cancel, and finally we will get that v1 tt also cancel. We will get v1 by v2. Here sin I by sin r is equal to, we got as v1 by v2. If we know one formula, nu is equal to c by v formula, we will write as c by nu. C is the speed of light and nu is the refractive index. And then from that sin I by sin r is equal to, we write v1 is c by nu 1. C is the speed of light in vacuum by refractive index. v2 is right as c by nu 2. V formula we know that is c by nu in the bracket I gave. v1 is c by nu 1, v2 is c by nu 2. C is will not changes. Then we will get as nu 2 by nu 1. Something c will be cancelled. You will get nu 2 by nu 1. This is nothing but sin I by sin r is equal to 1 nu 2 we write. Then we derived the Snell's law, right? This is equation 2. That means laws of refraction is proved, the first law. Okay. Therefore, the Snell's law is proved. Snell's law proved, that is sin A by sin R is equal to constant, that is equal to refractive index of second medium with respect to first medium. And the second, from the figure, second law also we have to verify. The second law is that directly rewrite. From figure you see, from figure, incident wavefront is AB, refracted wavefront is A dash B dash, and normal drawn is N. All are in the same plane, all are in the paper. Then we write as incident wavefront, incident wavefront. Okay, you don't write like this. Yeah, I'm not have the place, that's why I'm writing. Incident wavefront, comma, refracted wavefront, comma, and incident wavefront, comma, refracted wavefront, and normal are in the same plane, are in same plane, are in same plane. That means the second law is also verified directly. Then we say that the laws of reflection, sorry, laws of refraction we verified by using the plane wavefront. Okay, and this is very important for the 3 marks. They will ask the derivation, whatever that is appearing uh, in the board now. Okay, in the screen, on screen, whatever it is appearing, that is if you write, then you will get the 3 marks. This is very important for the 3 marks, and it is not required to write the theory. We wrote the theory like this, and this is going like this, that is going like that. That is not required. Verification is required. This verification is important, and whatever that it is appearing on the board, and it is important. Okay, and it is completed. This is about refraction of plane wavefront, and next I am going to start the reflection of plane wavefront, and after that I will close today's session. Okay, and till now, uh, is it clear, and what is your feeling? Are you understanding each and every step? Can I continue? Anyone can test the message or in the chat box. Is it clear? Okay. Next, I am going to continue. Very important topic we are going to discuss. I am going to erase this, and you note it very carefully. Here, everyone. Test the message. Yes, let us start. No one typing the test message. Is there any problem? Do you have any problem? Okay. Our topic is reflection of plane wavefront. Reflection of plane wavefront. Very carefully you have to listen. That is verification of laws of reflection by using Huygens principle. Listen very carefully. This is our topic, and anyone there is a chance to get for the 3 marks either refraction or the reflection. Very important. And let us start. We will take one boundary, right? This is a reflecting surface. It's a reflecting surface. It's a mirror, just like this is the mirror. Now, on the mirror, the light rays are incidentally. Let's take the two light rays. This is the first light ray. It is incidenting it here, and this is the second light ray. It is incidenting on the mirror. It is a reflecting surface. Reflecting surface. The light rays incident undergoes reflection. And the wavefront is incidenting like this. This is the wavefront. You know that wavefront will be perpendicular like this. This is the wavefront. It makes 90-degree with the light ray. It is makes 90-degree with the light ray. Like this, the wavefront is incidenting. The wavefront will be moves along with the light rays. And now the wavefront is allowed to incident it here. This is the incident wavefront. This is the incident wavefront. Okay, incident wavefront. And now it makes 90-degree with the surface. AB is the incident wavefront. AB is the incident wavefront. And here we draw the normal drawn. Okay, and this is the normal drawn at point A. This is the normal drawn at point A. When light ray incident at here, it undergoes the reflection. It undergoes the reflection. It will travel like this. This is the first light ray. This is the second light ray. The first light ray will go like this. The second light ray also undergoes the reflection and goes travel like this. After the reflection, the two light rays will go like this. And what is the angle of incidence at here? This is the angle of incidence. Angle of incidence is the angle between incident light ray and normal run. This is the normal run. Okay, this is the normal run. This angle is called as the angle of incidence. Okay, and from the mathematics, when this angle is I, when this angle is I, and this angle is 90 minus I, this blue line and this normal. Why? Because this total angle is 90. And now from the mathematics, okay, you will get this angle from normal, violet normal and blue. Angle between the NAB. Angle between the NAB. This we can take as A dash. From the figure, angle between the NAB become 90 minus I. No need to write that one. NAB angle will become 90 minus I. And this is 90 minus I means automatically this will become I, because again NA dash is 90-degree total. And then we write here this angle is I based on mathematics. Okay. And this angle is I means this angle also we will get I. And now this is the AB is the incident wavefront here. You see AB is the incident wavefront. Wavefront is incident. Reflected wavefront I want. Okay. You see here, when second light ray travel from first light ray, when first light ray is at A, second light ray is at B. When second light ray goes further forward and incident on the reflecting surface, the first light ray undergoes reflection and it travel from A to some distance. Then for that, what you have to do it here, we have to draw the normal at here. I will show, and this is the 90-degree. Let us consider, and this is the B dash. Okay, when second light ray travel from, you listen very carefully. You listen very carefully, and this is the situation. First light ray started at here. Second light ray started at here. Both are going forward, and the first light ray reaches the point A. Second light ray reaches the B point. Second light ray further it is moving from B to A dash. In that time, the first light ray reflects and travel from A to B dash. Okay. Then here, this angle is called as angle of incidence, or this angle is called as, also this is also called as angle of incidence or the angle of reflection. It is the reflected light ray. It is the reflected light ray. An angle between the normal drawn and the reflected light ray is the angle of reflection. But angle of reflection and angle of incidence both are equal. And from the mathematics, you will get the angle here as R. And here we have to write some theory regarding this. You listen very carefully. This is the incident wavefront. Wavefront is incidenting like this. Then after that, it will reflects. It reflects and it will goes. This A dash B dash A dash B dash AB blue line is the incident wavefront. Incident plane wavefront. And A dash B dash is the reflected plane wavefront. Reflected plane wavefront. And the reflected plane wavefront will be travel like this. It will go like this side. And now I is the angle of incidence. I is the angle of incidence. R is the angle of reflection. Here it is reflection it is going on. Angle of reflection. And let us consider c is the speed of light in this medium. Here the light ray is undergoes reflection, then light ray is not entering into the other medium. That's why the speed is remains constant. And here when second light ray travel, when second light ray travel from B to A dash, in that time first light ray reflects and travel from A to B dash. Then we know distance is equal to speed into time. We write B A dash is equal to speed is considered as a c into t, and A B dash is also we will get as c into t only. Why? C is the speed of light. Here it is moving in only one medium, no change in the medium. That's why okay, this is medium one total. Medium one, no change in the medium. That's why this speed we write same. Previously the medium is changed. But once again the figure when second letter travel from B to A dash, the first letter when second letter is at B, from the beginning. When second letter at B, first letter is at A. Then second letter further it is going forward. Then incident on the reflecting surface. At that moment, first letter undergoes reflection and travel from A to B dash. Then the distances are equal. Then we will get like this. These distances should be equal. Actually, this blue line little bit down we have to draw. And right diagram already rub ho gaya. Listen very carefully. I will try to redraw the diagram. Okay, right. This is the redrawn the diagram. Continue now. Within 5 minutes it will be complete. And now I'm going to take one thing from the triangles. One triangle you take as A B dash A dash, and another triangle you take as A B A dash. You see the two triangles with the cursor I will show. A B dash A dash. A B A. These are the two right angle triangles. In that angle at B is equal to 90 degree and angle at B dash is equal to 90 degree. Okay, and one more point is that AB dash is equal to BA dash. Then from that we say that these two are the congruent triangles. In congruent triangles, opposite angles are equal. Opposite angles are equal means we write angle of incidence is equal to angle of reflection. This angle I, okay, angle at A is equal to angle at A dash. Angle at A is I and angle at A dash is R. These two should be equal. Okay, and directly we can write. Or otherwise we can write from the triangle also. You take the triangle A B A dash triangle you take. From that you write the sin I. Sin I is equal to opposite side. I opposite side from the AB A dash triangle. You see here AB A dash triangle. AB A dash triangle. Sin I is equal to opposite side. B to A dash. B A dash by we write A dash. Okay. Sin I opposite side. I opposite side B A dash and hypotenuse is always perpendicular opposite to perpendicular. A dash is the hypotenuse. And this we write as CT by A dash. This is equation 1. You take the screenshot and note it, and then I am going to erase and I will continue it here on the right side. Within 5 minutes, I will close today's lecture. Okay, let us start. And one more triangle we will take, that is previously AB A dash is completed, right? And then next triangle is AB dash A dash triangle. From that sin R is equal to, we write sin R is equal to opposite side. Opposite side R opposite side. You see the figure. This is the AB dash A dash. R opposite side is AB dash. AB dash by hypotenuse is A dash. This we write as a CT by A dash we write. And this is equation 2. And from equation 1 and 2, right, what we write? The right sides are equal and that's why the left sides also equal. Right? And from equation 1 and 2, we write one thing. From equation 1 and equation 2, right side CT by A dash is there. That's why the left sides also equal. And we will get sin I is equal to sin R. Then we write I is equal to R. That means the first law is verified. That is angle of incidence is equal to angle of reflection. Right? Angle of incidence is equal to angle of reflection. Angle of reflection. And the second point is that from the figure directly we draw. Right? From figure, incident light ray, comma, reflected light ray and a normal run are in the same plane. Are in the same plane. From the figure directly we write here. This is the incident light ray AB and A dash B dash is the refracted light reflected plane wavefront or the light ray. Okay, and normal drawn all are in the same plane. By this, laws of reflection are verified. Okay, here we write incident plane wavefront also instead of light ray. Incident plane wavefront, reflector plane wavefront, normal drawn all are in the same plane. Then the plane wavefront obeys the laws of reflection. Okay, with these two important topics we completed. One is verification of laws of reflection by verification of laws of reflection verification of laws of refraction and verification of laws of reflection. Then both are completed, right? Thank you for watching my lectures. And today lecture is completed, and the remaining we will continue in the next class. Thank you to all.